So let's start today's video. In today's video, we will continue the part 2 of chapter 5. So let's start with the topic cell variables. Yes, so let's go. And in cell variables, we have environment variable. Environment variables are system-wide variables like $home and $path. Then we have user-defined variables. They are custom variable names like given by the users and given by the developers, unlike the environment variable. So inside the user defined variable we have some name, like if we want to store someone's name inside a variable, we can name this variable like name and then store inside the double quotes the name, and we can also print the name this way, echo $name. Then process. What is process? A process is a running instance of a program. A running instance of a program is called process. An instance is, if it's not running, then it's not process. Basic idea of the Unix process. Every running program in Unix is a process, just like I said, and each process has a unique process ID. Each running process has a unique process ID. Then displaying the process attributes. PS shows active process, and PS minus AVX, it lists all processes with details. Now, how can we display system processes? If you want to display the system process, you use the top. Then the top command displays live systems processes. HTOP, interactive process monitoring tool. Then a process creation cycle. What is the process creation cycle? Is one of the important questions. It may come in your exam, college and university's exam. So the process creation cycle includes three steps. First step is parent process. It forks a child process using fork command. The fork function, you can say this is the parent process forks the child like this, and then the child process executes a command using exe functions. This is how the child process execute a command. Then parent waits for the child and finish using wait. The parent waits and waits for child to finish using wait. Then cell creation steps. What are the steps in cell creation? First step is init. It first process started by the system. Then the get t means it waits for the user login. It waits for the user login. Then login authentication authenticates user. Login command authenticates user. The cell, it provides command line interfaces. It provides command line interfaces. Then the process starts. Process starts. Running, actively waiting, actively executing. Sleeping, waiting for an event. Zombie, completed execution but not removed from the process table. Zombie, completed execution but not removed from the process table. Stopped, stopped, suspended by user, suspended by the user. Those are the process states, and each process is important. Like the running state is actively running, sleeping is waiting for an event. That's why sleeping is zombie state. So as you know, zombies are dead, but it's walking, like walking up the dead walking dead. There are many movies of zombies, so it's a typically dead creature actually. And so that's why it's because it's completed execution but not removed. Because it's complete execution, the normal rule is if a process is completed, then the process will be removed. But when the process creation execution is already completed but it's not yet removed from the process table, it's considered as a zombie state. And stop is suspended by the user, is stopped. And zombie state, just as I said, it occurs when a process finishes execution but its parent has not collected its exit status. As I said that if a process completed its execution, its parent should collect its exit status. If the parent collects its exit status, it will confirm that the process is successfully completed its execution. But when it's not occur, when it doesn't occur, but on the other hand, the process is already finished execution, so it happens, the zombie state occurs here. Then it fixed using wait in the parent process. We can also fix the zombie state by using the wait function or wait command in the parent process. And then the background jobs and no hop. So what is this? The background command and run process command. This command, it run processes in the background. And no hop command and no hop command and runs in the background and ignores logout signals in background and ignores logout signals using signals to kills process. Kill PID technicals, the terminates the process. Kill PID terminates the process. Kill -9 PID forcefully kills the process. The P kills process name, kills process by name. Sending jobs and background foreground. BG resumes a suspended job in the background. FG brings a background job to the foreground job to the foreground. So resumes a suspended job in the background. Resumes suspended job in the background. Then FG brings foreground jobs to the background jobs and the foreground. The listing job. How can you list job? You can by writing the job to list the background and suspended job. We can list them. Then suspending and killing job. How can we suspend and killing the jobs? By using Control Z, we can suspend the job. Kill percentage job number kills a job. This person, if we kill percentage and the number of jobs we want to kill, then we have to specify here. It kills a job. Execute at specified time. Execute at specified time at 10 o'clock. Runs a command at 10 a.m. and battery. The execute commands when system loads is low. So runs the command at 10 a.m. This is how we can automatically start a command. So we can run a command when we are not available by specifying the time. And battery, it executes command when system load is low. Okay, so that's all for this chapter. Part 2 is completed. In the next video we will discuss about the chapter 6, customization and use of environment variables. So that's all for today. If you like this video, give us a thumbs up and subscribe to the channel and stay updated. So share with your classmates. I will catch up in the next video.